Hi guys, let's do the 4-2 homework. So here we are. We got ourselves some rational functions and we have a graph and we're trying to see which of these could be the graph. And we don't have a lot to go on here other than something really cool, are asymptotes, all right? Asymptotes are imaginary lines. They're not part of the graph, okay? The graph of the functions is really just this curve and this curve. However, there are these imaginary lines. There's one right here. Boop. And there's one right here. And these are lines that our graph will approach forever and ever. I mean, if we could keep zooming, we would see that it's still just a little away from this line. No matter how close it appears to be, no matter how much it looks like it's completely horizontal on top of our line, it's actually not, okay? It's always going to be just a tiny bit away. And that's what an asymptote is. It's a line that our graph approaches but does not touch. We've got two. We have a vertical one right here, and we have a horizontal one right here. The horizontal one's equation, we can tell, since it's the x-axis, is y equals 0. Now remember, you can't say that the horizontal asymptote is 0. It's not 0. It's y equals 0. 0 is a constant, just a number. This is a line that goes forever to the left and right, so you got to give me an equation for it. Next, we can look at the vertical asymptote, which has an x equals equation. And unfortunately, they didn't label this at all, the axes or anything. I don't know if this right here is 5 or 2 or 1/2 or a million. I have no idea. All I do know, though, because of the fact that it's on the right side of the y-axis, I only know that it's a positive number. Okay, so now let's go over here and see what we got. Which of these equations has a positive value for the vertical asymptote and a 0, y equals 0 for the horizontal asymptote? When we talk to Bobo Button, Bobo tells us that if the degree is bigger on the bottom, then 0 is the asymptote. So whichever function has a degree bigger on bottom has a y equals 0 horizontal asymptote. So let's go see. This one, the degree of the top is 0. There's no x. It's just a constant. That's 0. The degree of the bottom is 1 because the exponent on that x is 1. So it is bigger on bottom. This one's in the running. This one, degree of the top is 0. Degree of the bottom is 1. It is bigger on bottom. 0, 1, bigger on bottom. 0, 1, bigger on bottom. 0, 1, bigger on bottom. So that kind of didn't eliminate a single thing for me, okay? All of these have the same horizontal asymptote at y equals 0. But this is going to have to be what saves us, okay? Which of these has a positive value for the equation of their vertical asymptote? If I figure out what the asymptote is here, it would be what makes the denominator equal 0. So what makes x plus 2 equals 0? And that's a negative 2. So it's not this one. 3 makes that 0. That is positive. So this one's vertical asymptote is at x equals 3. This one is totally positive. That could be it. This one's vertical asymptote is at x equals 6 because that's what makes that 0. This one's is at negative 6. X equals negative 6. So that one is not. And this guy has a vertical asymptote at x equals 2. So that's that one. Okay. Let's change the equation so that it has an asymptote Oh my gosh, I just realized 4, 2 is the vertical asymptote section. So forget horizontal asymptotes, guys. It's not going to help us in this section. We're only focusing on verticals right now. Okay, we're going to change the equation so that it has an asymptote at the dashed line. So we want a vertical asymptote at negative 1, 2, 3. X equals negative 3, which means we need an x plus 3 in the denominator. All right, that way when negative 3 gets plugged in for it, we get negative 3 plus 3, which is 0, which means that we get a 0 in the denominator, which is the big no-no that creates that asymptote, all right? So that's the change I'm making. For this one, we want a vertical asymptote at x equals 5. So we need x minus 5 in the denominator. So let's change that 3 to a 5. Let's write a rational function where there's an asymptote at x equals negative 2. Okay, let's say that y equals, I know I need a x plus 2 in the denominator because negative 2 turns that into a 0 in the denominator. Okay, and then the numerator. What can it be? What can it be? I have no idea. It doesn't matter. It can be whatever you want. Let's pick the 4 from the lesson that gave everybody so much trouble or confusion. It doesn't matter. You could put a 2, you could put a negative 7, you could put whatever you want in that numerator, except for x plus 2. If you put x plus 2 or 0, there are exceptions, things that will mess up our fraction, but otherwise any other normal number is fine. Okay, we want a function that where x is less than 0 when f of x is greater than 0. This is math talk. Less than 0 is math talk for negative. Less than 0 means negative. And greater than 0 is math talk for positive. So we want a function where when x is negative, so this way, to the left, y, remember that f of x is y is positive, which means up this way. So if you remember, you guys, we've been looking a lot at our functions, these rational functions, and they tend to have this kind of shape, all right? This is like 1 over x. A lot of these will have the exact same shape going, all right? These functions we've been looking at. How can we make it, instead of being here and here, how can we make it appear in this quadrant like this problem wants? Well, one idea I have is to make it negative, right? Wouldn't a negative just flip this one down and that one up and give us that shape? So don't forget your transformations, guys. A negative does flip our graph still. Meets that requirement. We want one that has 2 positive vertical asymptotes. Here we go. Y equals 1 over. I'm choosing 1. Maybe you want to choose 10 or negative 10. Okay, or 40. I don't care. All right, put something in the numerator. And then in the denominator, since we want 2 asymptotes, we're going to need 2 factors. And we want them, we put x in there, we want them to be positive, which means we need to have opposites in here, minus, and then pick any 2 numbers. How about 1 and 2? All right. Okay. So that's it. That does it. All right. Which of the following has a vertical asymptote when x is a negative value? That one. So remember, you guys, they're trying to throw you off with the numerators here. Negative, the negative. Ignore that, all right? The only thing that matters is the denominator being 0, all right? So what number makes the denominator 0? In this one, 10 makes the denominator 0. 10 minus 10, 0. In this one, 5 makes the denominator 0. 5 minus 5, 0. And then in this one, -1 makes the denominator 0 because -1 plus 1 is 0. So which is it? Only 3. Okay, let's write an equation for a rational function that has a vertical asymptote for a negative value of x. We just saw one, so you could write that same one, though that might be a little bit cheating. So why don't we write it just a little different? Because the numerator doesn't matter. All right, you can put any number there as long as this is a plus. Then it will cause x to have to be negative to turn it into 0. Okay, now we want one where it has an asymptote if x is 0. So what makes x 0? Or what kind of situation makes it 0 when you plug in 0? Just a plain old x. That's going to turn into a 0, right? If I put a 0, you see it? I see it. And then we want one specifically that turns into 0 when x is 4. So then we have to do a minus. This is a positive 4, so we need a -4. Now 4 minus 4 does make that 0. Okay. Let's evaluate the function for these values. Sure. F of 10 means plug 10 in for x. So 1 over 10 minus 5, which is 1 over 5. Boop, boop, boop. I know you guys love decimals. It's 0.2, okay? But you don't need it. You don't need that 0.2. You can just put 1/5. If x is 100, we get 1 over 100 minus 5, which is 1 over 95, okay? And if you love your decimals so much, this decimal, you're going to have to figure out on your calculator. I don't know, okay? Cool. It's like 0.01. I don't know. I'm letting it go. Okay, 1 over 1,000 minus 5 is 1 over 995. Which is 1 over 995, unless you want to tell your calculator to turn it into a decimal. Okay, all good. This video is not too long. Should we just keep going and do 4-3 also? Okay, let's look at this. Okay, now horizontal asymptotes are in play. Okay, we're going to select all the equations that could represent this. This one has itself a vertical asymptote at x equals 0. And it has a horizontal asymptote somewhere here at y equals, and we don't know y equals what, okay? Because they didn't mark the axes with numbers for us. All we know, because of the fact that it's above the x-axis, we just know that it's a positive number. So let's go see what that means. If there's a vertical asymptote at x equals 0, that means that me plugging in 0 for x should cause a 0 in the denominator. Like something divided by 0. So look right here. Look, look, look. Ah, what happened? I zoomed in on purpose. Okay, right here, if I put a 0 in instead of x, do I get a 0 in the denominator? Sure do. If I put a 0 in the denominator here, I'm sorry, if I put a 0 in for x there, do I get a 0 in the denominator? I do. If I put a 0 in for x, does that put a 0 in the denominator? It does. Over here, if I plug in a 0 for x, okay, I'm not going to just write it like I did the others because it's going to look like 20, but it's not. This is, let's do it like this, 2 times 0. So 2 times 0 is 0, but then we're going to add 1, and our denominator is going to become 1. So did plugging in 0 for x make the denominator 0 this time? It didn't. Okay, it made the denominator 1. So this one is actually not a possibility. And then for this one, again, if I let x be 0, then it is 0. Okay. So we were only able to eliminate one choice using our vertical asymptote, which means that our horizontal one has to tell us the rest. Our horizontal asymptote is a positive number, okay? Let's go talk to Bobo Button, you guys. Remember Bobo? Bobo says if the degree, it wants to know about degree. If the degree is bigger on bottom, then y equals 0 is the vertical asymptote. If the degree is bigger on the top, it's Bobo Button, then we don't have a vertical asymptote, okay? And finally, what if the degrees are the same? What if the exponents are the same? If the exponents are the same, then we must divide the coefficients. So we must divide coefficients. Wow, it just turned into it out of nowhere. Okay, so let's go see here, okay? This Bobo Button, by the way, you guys, we use this whenever our function is just a fraction. Like, just, what's happening? Is it because I'm resting my hand on it? That's not fair. When our function is just a single fraction, we use Bobo Button. So we're going to use Bobo Button for this one because it's just the function is one fraction. And we're going to use Bobo Button for this one because the function is one fraction. And we're not going to use Bobo for these two. Okay, Bobo says if the degree is bigger, exponents are the same, then you divide the coefficients. So let's go see. The degree of the top here is 1. The degree of the bottom is 1. So they are the same. So we take the coefficient of the top one, which is 2. Not the 1. We only want the coefficient of the term that determined the degree. So 2. And we must divide it by the coefficient of the bottom term, which is 1. 2 over 1, which is a positive number. So this is totally a possibility. And we have the same exact situation here. They just switched the order. Actually, these two are exactly the same function. 2x plus 1 is the same as 1 plus 2x. So this one also, okay? The degree is 1 on top. The degree is 1 on the bottom. The coefficient is 2 on top. The coefficient is 1 on the bottom. It's the same. All right. Now let's look at these two. Because these two, you guys, this portion, just a simple old, good old curve that looks like this with a horizontal asymptote at y equals 0. But now it's growing legs and it's going to move down 3. So the asymptote will also move down 3 and become y equals negative 3. So that one cannot be it. This is a function with the asymptote at y equals 0, but then it got up and moved up 3. So the asymptote also gets up and moves up 3. So this one's asymptote is at y equals 3, which is a positive number. So that's also a possibility. Okay. Here's a function. It says, write the equation of the asymptotes. Sure. I see a vertical one at the x-axis. I'm sorry, the y-axis. So the equation of the vertical asymptote is x equals 0. And please remember, you can't say 0. You have to say x equals. And horizontal line right here at negative 5. So I have to say y equals negative 5. Okay? I don't know what's happening with this. What am I doing wrong? If you know what I'm doing wrong, tell me when you see me, please. Because I don't know what's going on. Why is my iPad doing this? Okay. And then lastly, they want me to write an equation. Okay. Let's say that a of... Oh, God, you're so annoying right now. Let's say that a of x equals... I know it's a fraction. And I know it has just x on the bottom. Because I know that 0 is supposed to put a 0 in my denominator. okay? That's what vertical asymptotes. Vertical asymptotes come from 0 in the denominator, okay? Vertical asymptotes, they come from a 0 in denominator. And then the horizontal asymptote, we figure out with Bobo. And Bobo says that it's either 0 or none. Or if it's a number, then you must have the same degree on the top as what you do on the bottom. So currently my bottom's degree is 1. This is x to the first power, which means I also need an x to the first power on top. And then when I divide the coefficients, I should get -5. So the coefficient of the top, if it's -5, then divided by the coefficient of the bottom being 1, does give me that -5 for the asymptote. But you guys, right now, this is not done. This is a problem. The problem here is technically the way I've left this x and this x cancel out, okay? They cancel each other out, and then I'm left with not a rational function anymore. So, gosh, what a disaster. Okay, so what I gotta do is make it so that I can't just cancel out those x's. You could do this in a million ways, okay? You can add something to the top. God, so annoying. I can't do this anymore, guys. I might have to stop this video, restart the iPad, make a new one. You can add something to the top or the bottom or both, okay? Just make it so that, oh no, wait, sorry, you can't add to the bottom, take it back. 0 needs to turn the bottom into a 0. And if I add something, I'm gonna change that. So only add something to the top, and that's it, we're done. Okay. Here I am, I'm going to sketch the graph of each rational function. So let's go gather our info. I have a vertical